In this episode, we focus on the pipeline that turns an AI idea into something that runs in the real world, because the pipeline is where repeatability and safety either become routine or become a constant struggle. A pipeline is the set of steps and handoffs that move work from building to training to deployment, and it includes the people, systems, approvals, and evidence that go with those steps. Beginners often imagine security as something you add at the end, right before you release, but pipelines prove why that approach fails. If the pipeline is not secure, you can train the right model and still ship the wrong one, or ship the right one in the wrong way, or ship it with hidden weaknesses. A secure pipeline is what makes safe releases repeatable, meaning you can improve the system over time without constantly reinventing controls or relying on heroics. The goal is to make the safe path the normal path, so each release builds confidence rather than creating new uncertainty. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to start is to understand what build, train, and deploy mean in a pipeline context. Build is where you assemble the code, configurations, and dependencies that make the system run. Train is where the model is created or updated using data, compute, and training logic that shape its behavior. Deploy is where that trained model, plus the surrounding application and controls, is placed into an environment where users or systems can interact with it. Each stage has different risks, and those risks can travel downstream if they are not managed early. A mistake in build might include a vulnerable dependency that later becomes an entry point. A mistake in training might include contaminated data that leads to unsafe outputs. A mistake in deployment might expose the model to unauthorized users or allow logs to capture sensitive information. Securing the pipeline means you treat each stage as a controlled process with clear inputs, clear outputs, and clear checks that prevent unsafe changes from slipping through. Repeatability is the central theme here because repeatability is what makes security scalable. If every release is a one-off effort, you will eventually miss something, especially as teams grow and changes accelerate. Repeatability means the same kinds of checks happen every time, the same approvals are required for similar risk levels, and the same evidence is produced so you can prove what happened later. Beginners sometimes worry that repeatability is bureaucracy, but it is actually a way to reduce cognitive load. When the pipeline is consistent, people do not have to remember every rule from scratch because the process enforces the rules. Repeatability also makes it easier to improve because you can strengthen one step and know that improvement applies to every future release. In AI systems, where updates can be frequent and behavior can shift subtly, repeatability is what prevents drift from becoming chaos. A secure pipeline begins with control over inputs because pipelines are only as trustworthy as what they take in. Inputs include code changes, configuration changes, training data, feature definitions, model parameters, and third-party components. If an attacker can change inputs without detection, they can change outputs without permission, which is the core of many supply chain problems. Even without an attacker, careless changes can introduce vulnerabilities or unsafe behavior. Securing inputs means restricting who can contribute, tracking what changed, and ensuring changes are reviewed with the right level of scrutiny. It also means knowing where dependencies come from and avoiding situations where unknown components silently enter the build. For beginners, the key is to see the pipeline as a gatekeeper, where every input should be authenticated, authorized, and traceable back to a responsible owner. Identity and access control are therefore foundational to pipeline security. The build and deployment systems themselves have identities, and those identities often have powerful permissions, such as the ability to push new versions into production or access sensitive training resources. If those identities are shared broadly or protected weakly, a compromise can become catastrophic. Secure pipelines use least privilege, meaning each identity has only the permissions needed for its role. They also use separation of duties, meaning the person or system that proposes a change is not the only one who can approve and release it. This reduces the chance that a single compromised account can ship malicious code or unsafe model changes. For beginners, a useful mindset is that pipelines should behave like secure vaults, where access is limited, actions are logged, and high-impact operations require stronger verification. When identity is handled correctly, the pipeline becomes harder to hijack and easier to audit. Build security also includes treating dependencies and artifacts as things that can carry risk. Dependencies are the libraries, services, and components your system relies on, and they can bring in vulnerabilities if not managed carefully. Artifacts are the outputs of the build process, such as compiled code, containers, packages, and configuration bundles that are later deployed. If artifacts can be modified after they are built, you lose confidence that what you tested is what you shipped. A secure pipeline aims to produce artifacts in a controlled environment and then protect them from tampering. It also aims to record what went into the artifact, such as versions and sources, so you can trace issues later. Beginners sometimes assume that once something is built, it is inherently safe, but security is about ensuring the artifact remains the same from build to deployment. This is how you prevent subtle substitution attacks where a safe build is replaced with an unsafe one. Training pipelines add special concerns because training creates a model that may encode patterns from data in ways that are hard to predict. Training inputs include datasets, labels, feature transformations, and the training code itself. If training data is poisoned, the model may learn harmful behaviors, create backdoors, or become easier to manipulate through inputs. If training data includes sensitive information without safeguards, the model might reveal it in outputs or embed it in ways that are difficult to remove later. Securing training pipelines therefore requires strong control over data sources, clear approvals for dataset use, and validation that data meets quality and policy expectations. It also requires careful handling of the training environment, because training often uses powerful compute resources and access to large datasets. For beginners, it helps to view training as manufacturing, where contaminated raw materials produce a contaminated product, even if the assembly process is otherwise correct. Another part of securing training is protecting the training environment from unnecessary exposure. Training environments can be attractive targets because they contain valuable data and because they may run with high privileges. If training systems are reachable from too many places or share credentials with other systems, they become stepping stones for attackers. Isolation is therefore critical, meaning training is separated from production and from general user environments so that compromise does not spread easily. Isolation also supports integrity because it reduces the chance that untrusted inputs can reach the training process. Beginners sometimes think isolation is only about networks, but it also includes isolating permissions, isolating storage, and isolating workflows so that changes are deliberate. When training is isolated, you can enforce clearer rules about what data enters, what code runs, and what outputs are allowed to leave. This is part of making training repeatable and safe rather than a risky experiment. Once a model is trained, it becomes an artifact that must be handled securely like any other high-value asset. Model artifacts can include weights, configurations, evaluation results, and metadata that describe how the model was created. If these artifacts are not protected, they can be stolen, modified, or replaced, which can lead to intellectual property loss or unsafe behavior in production. A secure pipeline treats model artifacts as controlled releases, meaning you track versions, restrict access, and ensure integrity from training to deployment. You also want traceability, so you can answer which data and which training settings produced a particular model version. This traceability is essential when you need to investigate an issue, roll back a model, or prove to governance that a model was built under approved conditions. Beginners should recognize that the model is not just a file. It is a decision-making component whose origin and integrity must be defensible. Testing in the pipeline is what prevents unsafe releases from being treated as learning opportunities at the expense of real users. In a secure pipeline, testing is not only about whether the system works, but whether it behaves safely and securely under realistic conditions. This includes checking that access controls still function, that logging and monitoring still capture key events, and that data protections have not been weakened by a change. For AI systems, testing also includes checking model behavior against known safety and quality expectations, because a new model version can change outputs in ways that affect risk. Beginners should understand that testing is a control, not a formality, because it produces evidence that the system meets requirements before it is exposed. If testing is skipped under pressure, pressure becomes the attacker's best friend, because rushed releases are more likely to contain weaknesses. The deployment stage is where pipeline security becomes visible, because deployment determines exposure to users and integration with other systems. Secure deployment means you do not treat production as a playground, because production mistakes can harm users and create hard-to-reverse consequences. A secure pipeline uses controlled promotion, meaning changes move from lower-risk environments to higher-risk environments with checks at each transition. It also uses clear approvals for high-impact changes, especially changes that affect data flows, access permissions, logging, or model behavior. For beginners, it helps to think of deployment as opening a door to the public. The more widely you open that door, the more certain you should be that the room behind it is safe. Deployment is not just releasing code. It is releasing risk decisions into real life. Continuous integration and continuous delivery, CI/CD, is a common concept that helps make pipelines fast, but speed without control is dangerous. CI/CD describes automation that builds, tests, and delivers changes frequently, which can be a positive force when it is paired with strong safeguards. In a secure AI context, automation should enforce the required checks rather than bypass them. Automation can ensure that code is built consistently, that tests run every time, that artifacts are signed or otherwise protected, and that deployments follow approved pathways. Automation also helps reduce human error, because manual steps are where mistakes and inconsistencies often appear. Beginners should see automation as a tool that can strengthen security when it encodes policies into the pipeline. The goal is not automation for its own sake, but automation that makes the safe path the easiest path. Evidence and auditability are essential outcomes of a secure pipeline, because Task 22 is not only about being safe, it is about being able to prove you were safe in a disciplined way. Evidence includes records of what changed, who approved it, what tests ran, and what artifacts were produced and deployed. It also includes logs of deployment actions and access events so that investigations can reconstruct what happened. A secure pipeline produces evidence naturally as part of its operation rather than as a last-minute documentation scramble. This is where the software development lifecycle, SDLC, mindset matters, because the SDLC is not only about building software, but about building software in a controlled, reviewable way. Beginners should understand that evidence is not paperwork. It is the memory of the system, and without it you cannot learn reliably or defend decisions. A major beginner misunderstanding is believing that security slows delivery and that safe releases mean fewer releases. In reality, insecure releases often slow delivery more because they create incidents, emergency patches, and loss of trust that disrupt progress. A secure pipeline can enable faster delivery because teams spend less time fixing preventable problems and less time arguing about what changed. When processes are repeatable, teams can move quickly while maintaining confidence. This is especially important for AI because models may need regular updates as data, threats, and user needs evolve. If each update feels risky and unpredictable, teams may avoid updates and allow systems to drift into unsafe behavior. A secure pipeline makes updates routine, which keeps systems safer over time and reduces the temptation to bypass controls under pressure. To close, securing build, train, and deploy pipelines for repeatable safe releases means you design the entire path from change to production as a controlled system of identity, integrity, isolation, testing, and evidence. You protect inputs so changes are authorized and traceable. You secure build artifacts so what you deploy matches what you tested, and you secure training so data and environments do not contaminate model behavior. You treat model artifacts as valuable and sensitive, ensuring versioning and integrity across transitions. You use testing as a meaningful gate that checks both security and AI behavior, and you deploy through controlled promotions that limit exposure until confidence is earned. When these practices are combined, the pipeline becomes a safety machine that produces consistent outcomes, allowing AI systems to improve without losing governance, reliability, or trust.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.